So I posed a few questions for you on synthetic division in the previous video. What I'm going to do now is I'm going to work through these questions, show you the solutions to them and how you can approach something like this. Quick reminder for you, this is what I asked you. So 1, using synthetic division, calculate the quotient and remainders of a x cubed minus x squared plus 2x plus 1 divided by x plus 2. And part B, x to the 4 minus x squared plus 2x plus 1 divided by x to minus 3. And then question 2 was find P if x minus 7 is a factor of x cubed minus 4x squared plus px minus 14. So let's get cracking. So imagine I've got this here. So I've got x cubed minus x squared plus 2x plus 1 divided by x plus 2. And I'm looking to use synthetic division. Now synthetic division, remember, is when we set it up using this and we use our coefficients here in order to make the division easier. It's a much simpler method and way of doing algebraic long division without all the steps and the levels beneath it. So we take the coefficients here and we set them up across the top. So my coefficient of x cubed 1, so that's there. X squared is negative 1, so it's there. X is 2, and then my constant at the end is just 1. Now x plus 2 is a root. We set that equal to 0, and what we figure out then is that x equals negative 2 for that to be the case. So that's the value I use here. That's the value that goes outside. Now we start by bringing our first value down here. We then go back up here and remember this one here is multiplied by whatever's out here. So in this case it's times negative 2. So I've got negative 2 there. I then go down this way treating it like a chimney sum. So I've got negative 1 plus negative 2. So negative 1 take away 2. I get negative 3. I then go back up this way again. Times it by the negative 2. Negative 2 times negative 3 gives me 6. Down this way like a chimney sum. 2 plus 6 gives me 8. Negative 2 times 8, because again I'm going to go back up this way, gives me negative 16. We then go down this way for the final part, and I get negative 15. So, what I've then done here is taken this, divided it, and I've got this here. Now this gives me the quotient. This gives me the answer when I divide it through, and this bit here is your remainder. So what I'm then able to say is x cubed minus x squared plus 2x plus 1 divided by the x plus 2 gives me, remember these are the coefficients now, but it's 1 powered down. So this is no longer for x cubed, this is x squared. This is no longer x squared, this is x. This is no longer x, it's the constant. X squared minus 3x plus 8 with a remainder of negative 15. So there's your quotient, there's your remainder. It allows me to do that. I could rewrite this another way if I wanted and say that x cubed minus x squared plus 2x plus 1 equals x squared minus 3x plus 8 times the part we've divided by times x plus 2, then take away 15. There's my remainder at the end. So I could write it that way if I wanted as well. Second example was this. So x to the 4 minus x squared plus 2x plus 1 divided by x minus 3. We set it up the exact same way again. Now the thing you need to watch with this one is there's no x cubed term in here. Alright, there's nothing there for x cubed. We don't just miss that out, we have to fill that gap. And in this case we fill that gap with a 0. We've then got the coefficient of x squared there, our x there, and our constant at the end. X minus 3 is what we're dividing by, so what that means is x minus 3 equals 0. We think of it in terms of that. So x is equal to 3. So that is my number on the outside. And again, we just start as normal. First number down, I take it up this way and I times it by 3 and I get 3. Chimney sum down the way, 3 plus 0 is 3. Again, times it by 3 and I get 9. Negative 1 plus 9 gives me 8. Times it by 3 going up this way again. 3 8s are 24. Bring it down, 24 plus 2 gives me 26. And then I've got one more step now to do. Times it by 3, so 26 times 3 gives me 78. Add the 1 going down, and I get 79. So I'm then able to say x to the power 4, take away x squared, plus 2x, plus 1, divided by the x minus 3, gives me, and remember the powers come down, so this was an x to the 4, it's now an x cubed, x cubed now becomes x squared, squared becomes an x becomes a constant. So that gives me x cubed plus 3x squared plus 8x plus 26, remainder 79. So that gives me that. So there's my quotient and there's my remainder right there. So that's those two questions. The last one was this. Find p if x minus 7 is a factor of this one here. One like this, we could still set it up the exact same way. So we still set it up with our synthetic division, and we still set up our coefficients. The only difference being in the x one, my coefficient now is going to be this whole unknown part. So my coefficient is going to be the p. And I've then got my negative 14 there. And again, we approach it the same way. If x minus 7 is a factor, imagine x minus 7 equals 0. X equals 7, we take that in. So I've got my 7 there, and I start it the same way. Going up the way, I times it by 7. 1 times 7, 7. Go down the way like a chimney sum, and I get 3. Going up the way, I times it by 7 again, and I get 21. Now the only difference being, when I do this like a chimney sum, I'm going to get something involving algebra. I'm going to get p plus 21. I then go up the way again, and multiply it by 7. So I get 7 bracket p plus 21. And then if I go down as a chimney sum, I get 7 bracket p plus 21, close bracket, take away 14. Now, that doesn't look like anything that could be useful. However, I've told you that it's a factor. Now remember, if it's a factor and we do synthetic division, we should end up with the same value here every single time. That should be equal to 0. So what that allows me to do is actually set up an equation and say, fine, so 7 bracket p plus 21, take away 14, has to equal 0 for it to be a factor. And then I can just solve it like algebra. So it's 7 bracket p plus 21 equals 14. Divide both sides by 7, and I get p plus 21 equals 2. So in this case, I know p equals negative 19. So I've calculated my value of p because I've used this fact here. If it's a factor, this has to equal 0, and we can set up an equation to solve it. Here's hoping that you did well with those. See you in class for having a bit more work on this.